All right, so what are we going to do today?
It has to do with like tangents and limits and motion and the tangent problem, I guess.
Okay. Not exactly sure what you mean, but
I'll bring it up. Hold on. I need to see what it.
so you've gotten into precalculus? Oh, you're talking about the limits of the tangent, the slope of the tangent line?
Yeah, that stuff.
Yeah, you're getting into calculus.
Yeah. All right. You just give me a second. I need to bring it up.
Pretty much the definition of differential calculus is the slope of the tangent line. Or we could say the rate of change of that function. What is the instantaneous rate of change of that function at that point right there? Notice that it changes as we go along this. In other words, the rate of change right there is different than it is up here.
Yeah.
That's what differential calculus is all about, is the rate of change of a function, or the slope of the tangent line. Same thing.
Okay. Okay. So, the first question I have is for exercises, write an equation for a specified line, and the line is through 1, 6, and 4, -1.
So they just want the equation of the line that goes through those 2 points?
Yeah.
Okay. Most important thing about a line is what? Slope.
Oh, yeah.
In other words, slope is whatever that angle is. If that line has this kind of a slope, it's completely different than if it has this kind of slope. So slope and some point completely defines a line. So the most important thing we have is slope. What is slope? What's the vernacular for slope?
It's x1 or
Rise over run. That's what I want you to remember.
Yeah.
As long as you remember rise over run, you won't get it backwards. What's the rise?
The rise is -5.
Well, the rise is y sub 2 minus y sub 1. And the run is x sub 2 minus x sub 1.
Yeah.
Don't get those backwards. In other words, it's always the vertical that's in the numerator. So, in this case, what's the numerator?
-7.
Okay. We can go whatever order we need to here. We can go this minus that as long as we go this minus that in the bottom. We could also go this minus that in the top, which would be 8, And then the bottom would be 1 minus 4. But we'll go your way.
Yeah.
Minus 1 minus 6 is minus 7. And 4 minus 1 is 3. So there's the slope. Now how do we come up with the equation? In other words, we've got the slope.
So then, well, we have the value for 1. So if you just add or subtract 7/3, no, it's add because you already added it. If you add negative 7/3.
Well, now hold on. What's the next step? In other words, I have a slope of a line, and I have 2 different points that it goes through. So how do I come up with the equation of that line?
You find 0. What is equal to when x equals 0?
Well, first of all, let's talk about what's the equation of a line look like. We've got this equation of a line, but we also have this equation of a line. This equation is slope-intercept format. This equation is point-slope format.
Yeah.
You want to know both of these formats. They both are the equation of a line. But very frequently, the only thing we have is a slope and a point. So when we have a slope and a point, let's use point-slope format.
Okay.
That it's easier than slope-intercept. Because if we use slope-intercept format, we know the slope, but we don't know what b is. So we would have to plug in one of these points for y and x and solve for b. Whereas if I want to do point-slope format, I can go immediately into point-slope format. Pick one of these points, either one of them, and we'll put it in point-slope format.
Top one.
Top one, okay. What's the point-slope format?
Y minus 1.
No, this is y sub 1. There's y sub 1.
Oh, yeah. Y minus 6 equals negative 7/3 times x minus 1.
Okay. And that's a perfectly acceptable answer as long as they didn't say give it to us in slope-intercept format. In other words, as long as the question was give us the equation of the line, that's a good answer right there. You don't need to do anything else with it. If they said put it in slope-intercept format, well, then we would need to distribute this and move the 6 over. In other words, we would have y minus 6 equals minus 7/3 x plus 7/3, and then when I move the 6 over, I get y equals minus 7/3 x plus 6 plus 2 1/3 is 8 1/3. So this would be slope-intercept format. But this is point-slope format. And notice that point-slope format was the easiest to come up with. It was one step.
Yeah.
If we had to come up with this, we could have done it, but we would have had to do at least 2 steps regardless of how we did it. So it's good to memorize both of these formats. Slope-intercept and point-slope. And you use whichever one the information you have. In other words, in this case, we have a slope and we have a point. So let's use point-slope format. If they would have given us the y-intercept and a slope, then we would have used this format.
Yeah.
Okay. else you got?
The next one, the next one is a line through 1,4, and it's perpendicular to 3/4 x plus 2.
So what is the slope of the line that goes through the point 1, 4?
4/3.
Yeah, so our slope of the perpendicular, it's not 4/3. You have to do two things. You have to flip it and you have to do something else.
Negative 4/3.
So our slope is negative 4/3. So there's our slope. There's our point. What's the equation of it?
It's y minus 4 equals negative 4/3 x minus 1.
Exactly. There's your answer. Like I said, unless they specifically request a certain format, any of these formats is okay to use. What else you got?
The next one is average velocity of a bicyclist and he travels 21 miles in 1 hour and 45 minutes. What is his average velocity during the entire time?
Okay, how many total minutes did he take?
105.
So it's 21 miles per 105 minutes. Now, can that be reduced? Yeah, 3 goes into both of these. 3 goes into the top 7 times, and it goes into the bottom 35 times. Oh, and then that becomes 1/5. So our answer is 1/5 mile per minute. There's our average rate. Now, let's just say something about that. Average rate is the stuff of algebra and precalculus. Instantaneous rate is the stuff of calculus.
Yeah.
If I want average rate, I take the rise over run between those 2 points. That'll give me the average rate.
Yeah.
If I want the instantaneous rate at 60 minutes, then it's the slope of that tangent line. And that's what calculus is all about. And that's what separates calculus from algebra and precalculus, is limits. Average rate is very easy. Just take rise over run. Average rate is the same as average slope. Where calculus is tough is coming up with the instantaneous slope.
Yeah.
And one way of talking about that would be, let's say you get in your car and you drive to Colorado Springs. Well, velocity is your instantaneous rate of change. That's actually a first derivative. So if you look down at your speedometer in your car and you're going 47 miles an hour, that's an instantaneous rate of change. At that moment in time, you're going 47 miles per hour. If it takes you exactly 1 hour to go 60 miles to Colorado Springs, your average velocity is 60 miles per hour. But that 60 miles per hour could come from, obviously you don't just go 60 and stay at 60 the whole way. Sometimes you go 70, sometimes you go 50, sometimes you go 45. So your average rate is quite easy to come up with. You just take your total distance and divide it. You got D equals RT. So if D equals RT, then your average rate is the total distance divided by the total time. But notice when you're looking at instantaneous, your total time is 0. And your total distance is 0. So you have 0 divided by 0. And that's not easy to come up with without calculus. And that's where calculus comes in.
Yeah.
So far as all you've really talked about is precalculus stuff. Average rates of change.
Yeah, that's what we're doing now.
Yeah.
I mean, we touched on it a little bit.
Yeah, no, you're doing a prelude to calculus. You'll get into limits pretty quick.
Yeah. All right. The next one is find the instantaneous velocity at the indicated value of t. And the function is s of t equals 3t minus 5. And t equals 4 when t equals 4.
Okay, so they want s of 4. Actually, they don't. They want the instantaneous velocity. And velocity is the first derivative of position. What they've given you is the position function.
Okay.
Reread the question because it doesn't sound right.
Okay, so the position of an object at time t is given by s of t. Find the instantaneous velocity at the indicated value of t, and the function is s of t equals 3t minus 5 at t equals 4.
Okay, so what I really want is this. The velocity at t equals 4. I don't want the position. The position at t equals 4 would merely be 12 minus 5, 7.
Yeah.
But that's not what they asked for. They asked for the velocity. Well, the velocity is the first derivative of position. So, I know how to answer this, but I'm not sure what they've taught you. If I want v of t, I take the first derivative of this function and I get 3. So the velocity is a constant 3. So v of 4 would still be 3. V of 6 would be 3. Your velocity is always 3 in this particular position function.
Yeah.
But I'm curious as to how they've taught you how to come up with that. Because there's lots of ways to come up with the velocity function based on the position function.
When he was doing it in class, it had he used letters and it was a lot like H's.
Okay, you're talking about this. You're talking about the limit of f of x plus h minus f of x all divided by h as h goes to 0.
Yeah.
That is the definition of first derivative. And velocity is the first derivative of position.
Yeah.
Okay, so let's do this. What is f of x plus h? This is actually the hard way to start out calculus. I don't really like the way that our schools teach geometry or calculus. Because what they do is they start out with a very, very difficult concept. And you got to get past that before you can get to the easy stuff. And in geometry, it's proofs. If you remember your geometry course, the first thing you had to do was get through proofs, and that was probably the toughest part of all geometry. Well,
no, we did that proof towards the end of the year.
Oh, well, good, good. That's the way it should be done. You should master the beginning slopes before you try to go in the expert slopes. Well, the same thing with calculus. This is the difficult way to find the velocity function. But let's do it. What is f of x plus h? In other words, what is our function is s of t, so what would be s of t plus h?
Would it be 3 times t minus 5?
No, we're going to put in t plus h instead of x.
Okay, yeah.
And then minus 5. And what is s of t? In other words, this is f of x, and this is f of x plus h. Okay, so let's go into our definition here. F of x plus h is 3t plus 3h minus 5. That's f of x plus h. We're going to subtract from it f of x, which in this case is 3t minus 5.
Yeah.
And we're going to divide that whole thing by h. And then take the limit of it as h goes to 0. Well, what does this thing equal to here when I do this manipulation? What am I left with?
You're left with 3t plus...
Well, the 3t's cancel. This 3 cancels with that 3t.
Oh yeah, and then the minus 5.
Those cancel also. So what am I left with?
3h.
Okay. Now I have this problem. What is the limit of 3h divided by h as h goes to 0?
3?
Yeah. The h's I can cancel. I don't care if h is going to infinity. The limit of 3, regardless of what h is going to, is 3. So the velocity is 3 everywhere.
Yeah. Okay, well then the next one is, it has s of t equals at squared plus 5 equals, and then at t equals 2. When t equals 2.
Okay. So let's find this limit. In other words, we're going to use the limit of f of x plus h minus f of x all over h as h goes to 0.
Yeah.
So what is f of x plus h?
It's A times T squared.
T plus H squared.
Squared. Okay.
In other words, I want to, whenever I talk about that, whatever is inside my parentheses is what I'm substituting for the variable.
Oh, yeah, yeah, yeah.
Okay? Plus 5.
And then my plus 5 over 8.
Minus, what's f of x?
2.
No, f of x is the original function.
Right.
At squared plus 5.
Okay.
I'm putting the whole thing over h, and I'm going to take the limit of this as h goes to 0. Now what's going to happen here is the numerator is always going to factor down to some h that can be factored out, and then that's going to cancel with the denominator.
Yeah.
And that's what always happens on these. So, what's the numerator become? Let's multiply this out.
So that becomes A times T squared plus TH, 2TH, plus H squared.
Plus 5.
Plus 5 minus H.
The second set of parentheses are very important. If you omit that second set of parentheses, you will get the wrong answer.
Yeah.
Because there's a negative sign in front of it, and there's always a negative sign in front of it.
Yeah.
Okay? So, let's simplify the numerator. So I got AT squared plus 2AHT plus AH squared plus 5 minus AT squared minus 5. Well, that cancels with that. That 5 cancels with that. Notice the only terms I have left each have an H in them.
Yeah.
So I've got 2AHT plus AH all over H. Well, that H, and that H all cancel out.
Yeah.
Leaving 2AT plus A.
Okay.
That's going to be the limit. In other words, I'm taking the limit as h goes to 0. Well, h isn't even in the equation anymore. So there's my velocity. And you said at what point?
At 2. When t equals 2.
Okay, they haven't defined a for us. So a is just a variable. But we can certainly substitute 2 for t, and we get 4a plus a, so we get 5a. There's our answer.
Okay. Yeah.
They're starting you off with some very obscure kinds of functions. I don't like it. I don't like the fact that they used a variable there, a. They didn't need to.
Yeah, that I looked at that after we did the one before where it was pretty simple to find the answer, and it seemed like a huge jump.
After you finish this section of calculus, you're going to find that they've got 5 really easy rules for finding first derivative. Let me just clue you in right now. If a function is that, then first derivative is 2x. You take the exponent, you stick it down in front, and you subtract 1 from the exponent. If this were my function, then the first derivative would be 12x cubed. This is the easy way.
Yeah.
The hard way is doing the limit quotient definition, which is what you're talking about. F of x plus h minus f of x all over h. That's the hard way to do it. Like I said, once they teach you the hard way, then they're going to give you the easy way. And that easy way is the way you'll use the rest of your life. You'll never do the hard way again. But who am I to question their method of teaching? What else you got?
All right, the next one is a rock is thrown straight up from level ground. The distance in feet the ball is above the ground is f of t equals 3 plus 48t minus.
Your audio is a little bit sketchy. You said, what do they call it? F of t?
F of t equals 3 plus 48t minus 16t squared.
Okay. F of t being the height at any point in time.
Yeah.
Okay, what do they want to know?
They said at any time t in seconds, find f to the power of 1, 0.
Well, that doesn't mean f to the power of 1. What it means is the first derivative.
Okay.
Okay? The first derivative means what is the instantaneous rate of change? In other words, let's look at this a little bit more. This is a quadratic, right? It's a quadratic that opens down. It's not at the origin, so it's either somewhere over here or somewhere over there. I don't know exactly where. We'll pretend it's over here. Okay? So they're saying, what is f prime, which means first derivative, evaluated at 0? Well, what that's really asking is, what is the slope of the tangent line when x is 0? Let me draw this quadratic a little different. Let me draw it like this. Well, you can see that the slope of the tangent line changes dramatically depending on where you're at on this parabola. Yeah. Slope is 0 there. Slope is positive here. Slope is negative here. So we need some way to figure out what f prime of t is. And once we get f prime of t, then we can plug in any t they want and come up with the slope of the tangent line at that point. So, like I said, there's the easy way and the hard way to come up with first derivative. I presume they have not taught you the power rule yet.
I don't think so.
Okay. So what we want to do is do f of t plus h minus f of t all over h and take the limit of that as h goes to 0. Okay. So what is f of t plus h?
It's f3 plus 48 and then t plus h and then minus 16 t plus h squared minus 3 plus 48 t plus or minus 16 t squared.
Yeah, and that's why those parentheses are so important, because you're going to get the signs wrong on these two-ladder turns if you don't use parentheses. Okay? So let's simplify this. And once again, you always can know that all the t terms are going to cancel out unless they have an h in them. So if we simplify this up here, what do we get? In other words, this part here, let's simplify. This becomes algebra, and that's plain and simple algebra. It's hard algebra,
Yeah.
but it's algebra. Okay, so we get 3 plus what?
3 plus 48t plus 48h minus 16t.
Got to square that t plus h squared.
Plus 2th plus h squared. Okay, so it's
In other words, now what's this part here?
minus 3 plus 48t.
Remember, there's parentheses there. Got to distribute that negative sign to every term inside the parentheses.
Oh, yeah, so minus 3 minus 48t plus 16t squared.
Okay. Now, what do we have? Well, we should get rid of these parentheses first. So let's do that real quick. We got 3 plus 48t. That's why this is the hard way, is because it's so much algebra. Minus 16t squared minus 32th minus 16h squared, and then minus the bottom, minus 3 minus 48t plus 16t squared. Now, we're taking the limit of this thing as h goes to 0, and this whole thing is being divided by h.
Yeah.
So what cancels?
The 48t, the 3's, 16t squared.
Notice that everything left has an h in it.
Yeah.
That's the key. So here's what we have left. 48h minus 32th minus 16h squared all over h. And we want the limit of that as h goes to 0. Well, the h is canceled. In other words, I can factor an h out from the numerator, getting rid of that, and one of those, and getting rid of that. So what do I have left? I have 48 minus 32t minus 16h. What is the limit of this expression as h goes to 0?
I don't know.
Well, what happens? Let h go to 0 in this thing. What do you have left?
Oh, 48 minus 32t.
Minus 32t. There's your answer. And they wanted what it was when t was what number?
When t is...
2?
No, it said what the function, the f with the little 1 on.
Okay. Okay. So that they didn't even ask you to evaluate it. In other words, f prime of t is equal to 48 minus 32t. There's your answer right there. Now,
and then the next
if they do want to evaluate it at any particular t, it's real easy to do. In other words, this is the first derivative function, so it doesn't matter if t is 0 or t is 5 or t is 10. You can figure out what the velocity of this rock is at any of those times.
Yeah. And then it asks for the initial velocity of the rock.
Well, initial means 0. Time is 0. When I plug 0, f prime of 0, that would be 48. In other words, I'm going to plug in 0 for t.
Well, I did it because in physics, when you do motion diagrams and stuff, where you track the motion of a flying object, you just, the initial velocity is the...
Yeah, it's the...
that
coefficient.
It's the coefficient of t, not t squared.
Exactly. The coefficient of t has to do with the velocity of the rock going up. Coefficient of t squared has to do with gravity, the force of gravity.
Yeah.
So what they're really saying is that this rock had a position of 3 feet in the air at time equals 0. Right?
Yeah.
In other words, if I plug in 0 for t up in the original function, I can tell that its height is 3 feet. So the person was releasing the rock at a height of 3 feet.
At 48.
At 48 feet per second. And this is always going to be the initial velocity in a problem like this. But you'll notice that we solved it using our first derivative function. We didn't solve it that way. You can solve it that way. But if this is a lesson on first derivatives as opposed to a lesson on projectile motion, it matters.
Yeah.
Velocity is the first derivative of position. Acceleration is the first derivative of velocity.
Yeah.
If I took the first derivative of this velocity function so that I had f double prime, which is the acceleration function, that comes out to be minus 32. The acceleration on that rock is always minus 32 feet per second, which is the acceleration due to gravity. But it's worth knowing, just for your information, that position, velocity is first derivative of position, acceleration is first derivative of velocity, or second derivative of position.
Yeah.
All right. What else you got?
All right, find the derivative, if it exists, for the function at the specified point. And the first one is f of x equals 1 minus x squared. And then x equals 2, so it's 1 minus 4.
No, it's not 1 minus 4. First of all, we have to find the first derivative of this function.
Yeah.
This function right here, if I were to graph it, it would graph like this. The parabola going through 1, facing downwards.
Yeah.
If I want the first derivative function, it's going to be the changes in the slopes. In other words, the slope is there, and then it goes 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 there. Notice that the slope, if I were to graph the slopes, it is, it starts positive, and it goes negative. So this would be f prime of x. This would be x.
Yeah.
In other words, the original function is a parabola, but the derivative of the original function is actually linear. It's a straight line whose slopes are, that's positive slope, That's positive, that's positive, that's positive. There it's 0, which is this point right here, has a 0 slope. And then all the slopes go negative, which are this area right there. All the slopes are negative. So they said find the derivative and evaluate the derivative at x equal 2.
Yeah.
All right, enough with the hard algebra. I'm going to show you the power rule.
Okay.
The power rule. If you have things being added or subtracted, you can differentiate each one of them individually. If I take the derivative of a constant, that's 0. Always, no matter what the number is. If I take the derivative of this variable, I take the exponent, put it down in front, and subtract 1. That's what I get.
Okay.
So the derivative function is minus 2x. So the derivative function evaluated at 2 is minus 4. But it's very important to evaluate the derivative function, not the original function.
Okay. So when you said you take the exponent and minus 1?
Yeah, here, let's just practice. This is so easy you're going to be shocked because...
Well, I'm confused about the minus 1 because it's just 2x.
What's the derivative of this function right here? Take the exponent, multiply it by the coefficient.
So 12x squared.
It's that easy.
Oh, so you subtract 1 in the exponent. I thought you were talking about the coefficient.
Enough with the nonsense of having to do all of that algebra. If this is my function, what's the derivative of it?
Yeah.
What's y prime?
It's 24x to the third.
That's it. It's as simple as that. Now, let's take a hard one. What's y prime here?
That is equal to x to the negative 1, so it's negative 1x.
You're close.
Oh, it's just negative 1 because...
No, it's negative x, but then you have to subtract 1 from the exponent. What's minus 1 minus 1?
0.
No.
Or 2.
Minus.
Negative 2. Oh.
It's really minus 1 over x squared. There's the derivative function.
Okay.
Using the power rule. Now, if I went back and used the f of x plus h definition, this is much harder to come up with. The algebra is tough. It really is. The algebra is very hard. But using the power rule is so easy that once you start using the power rule, you'll never use the other method again.
Yeah.
Just make sure you use the power rule properly. So let's try another one.
Well, I have one that it's absolute value of x plus 2. And then find it where x equals negative 2.
All right. First of all, it's worth plotting this. There's the graph of it.
Yeah.
Notice the slopes. It wants the derivative at negative 2?
Yeah.
Oy. You cannot take the derivative at corners or cusps.
So
This is a corner. or a cusp. There is no derivative. There is no value. It's undefined at -2.
Okay. But what is the function? Can you do the power
the
rule?
derivative of the function is -1 right there. No matter what point you're at, the slope is -1.
Yeah.
And the slope over here is +1. So for all x less than -2, f prime of x is -1. For all x greater than 2, f prime of x is +1. And for x equal to 2, f prime of x is undefined. You do not know what the slope is at that point where there's a corner. Notice that if you try to draw the slope of the tangent line there, you might come up with that, you might come up with that, you might come up with that. It's because you can't make the slope of the tangent line at a corner. There are certain functions that are not differentiable in their entire domain, and this is one of them. This is differentiable everywhere except -2. It's the only point that's not differentiable.
Yeah.
Let me give you another function that is not always differentiable. If I have a function like this, well, I can see that's differentiable everywhere. I can figure out the slope no matter where I'm at.
Would you use like a sine curve or something like that?
No, you take whatever the function is. Let's say that, let's make that function again. And let me call that function, it's got a couple of loops in it. Let's make it a cubic.
Oh, yeah.
Let's say that function is that.
Yeah.
If I want to find the derivative function, which would be the function that shows me the slope at every point, use the power rule. What's f prime of x?
It's 3x squared minus 4x plus 1.
Exactly.
Oh, yeah.
No, this one goes to 0. This one is 1. The coefficient is 1.
Yeah.
Okay? So this is the derivative function. So if they want to find out what the slope is at any point on the x-axis, you just plug it into the derivative function.
Yeah.
In other words, if I want f prime of 0, it's 1. What that means is the slope right there at x equals 0 would be flat. Not the way I've drawn it, but that's the way it should have been drawn.
Yeah.
I mean, I made up this function and I made up this, so this function doesn't necessarily fit this curve. But that's, I mean, derivatives are actually quite simple when you're using just the power rule. And you can use the power rule as long as you have nothing but addition and subtraction taking place in a polynomial. If I give you a function like this, now I got problems because I got multiplication taking place.
Yeah.
Now you have to use something called the product rule. Or if I had an original function like this, I've got to use something called the quotient rule.
Yeah.
There's all these rules that allow you to take the derivatives easier than the limit quotient definition. And no matter how hard these 5 rules are, and that's how many there are in differential calculus, they're all easier than applying the limit quotient definition, which is the f of x plus h minus f of x all over h. Like I said, that's the hard way. Once you get past that, You never go back and use it again. You use the 5 rules. The 5 rules being the power rule, product rule, quotient rule, the chain rule. That's it. There's only 4 rules.
Yeah. Okay.
Got about 3 minutes. You got a quick problem?
That was it. That was all I got.
Okay.
I had.
Let me give you a few more practices here. Now you're familiar with when I write y prime, you're familiar with that means. In other words, a lot of these terms mean the same thing. dy dx is the same as y prime. It's the same as f prime of x. It's the same as delta y over delta x. All of these mean the same thing.
Yeah.
It's just some of them are a little more descriptive. This one tells you you're taking the derivative relative to x. This one doesn't really say that. It just says you're taking the derivative. This one tells you you're taking the derivative relative to x. And so does this one over here. So some of the notations make a little more sense than others. Probably the best notation is this one right here, dy dx. So what would dy dx be equal to here?
20x.
Take the exponent, multiply it by the coefficient.
Negative 20x minus the negative 6.
So I could call that y prime, I could call that f prime of x, I could call it everything, but this is the derivative function of this.
Yeah.
Heard a great explanation for calculus once. Arithmetic is the manipulation of numbers. Algebra is the manipulation of variables that represent numbers. And calculus is the manipulation of functions. Not numbers, not variables, but functions. This is a function up here. So when I apply calculus to that function, I am manipulating that entire function to get this. And that's what both differential and integral calculus is they're both manipulations of functions.
Yeah.
And this power rule can be applied as long as you're just adding stuff. In other words, if I had a plus 2x minus 10, then my answer would be minus 20, x to the minus 6 plus, well, this is 2, because notice that if I subtract 1 from that exponent, I get 0, and anything to the 0 power is 1. So that's why the derivative of 2x is 2. And this, the derivative of any number, is 0. So this is y prime.
Yeah.
All right. It's probably a good place to stop. Well, this is exciting. I love tutoring calculus. I'm glad you're getting into it already. That's what I thought. I think I said that last time I talked to you, that I'll bet you're headed into limits and calculus.
Yeah, I think you do.
Yeah. All right, Lucas. I will talk to you next Wednesday.
Yep.
Bye-bye.